These are the newest images of 3i Atlas from yesterday, and I'm pretty sure this is actually the most shocking anomaly we've seen about this object, because the only possible explanation until now was that it's breaking apart. But the new images reveal something far stranger, a green glow surrounding the nucleus that appears and disappears, changes intensity, and behaves in ways that no natural comet has ever behaved before. So in this video, I'll break down everything we know about what's actually happening with the green mystery glow of 3i Atlas. Because what we're seeing So in this video, I'll break down everything we know about the spinning motion of 3i Atlas, what the footage actually reveals, and why this rotation behavior is completely inconsistent with what we expect from natural comets. So let's start with what we're actually seeing in these new images. Between November 16th and November 23rd, 2025, multiple observers captured something extraordinary. Images from Ray's astrophotography, observations from Diego San Araujo in Rio Hurtado, Chile, and footage from amateur astronomers around the world all show the same phenomenon. 3i Atlas appears to be spinning, not just rotating slowly like a typical comet nucleus, but displaying visible motion patterns that can be detected within minutes of observation. When observers stack multiple images taken over short time periods, they see the structure around the nucleus changing position and orientation. One observer stated that when you visually see it, it might be moving slowly, but you could see it moving for sure. Within a minute, you should see a different shape or a different position. That's not normal. That's not how comets behave. In typical comets, rotation is measured over hours or days through light curve analysis. You watch how the brightness changes as different parts of the surface rotate into and out of sunlight. But with 3i Atlas, observers are claiming they can see structural changes within minutes. Let's talk about what we know about 3i Atlas's rotation from scientific measurements. Light curve analysis suggests a rotation period of approximately 16 hours. This is relatively slow for a small body, but not unprecedented for comets. A 16-hour rotation period means the object completes one full rotation every 16 hours. That's about 22.5 degrees per hour, or about 0.375 degrees per minute. At that rate, you wouldn't expect to see visible changes in structure over the course of a few minutes of observation. But that's exactly what observers are claiming. They're seeing the coma, the cloud of gas and dust around the nucleus, shift position and change shape over periods as short as 1 minute. How is this possible if the rotation period is 16 hours? One possibility is that what we're seeing isn't the rotation of the nucleus itself, but rather the rotation of structures in the coma. Maybe jets or dust streams are rotating faster than the nucleus, but that doesn't make physical sense. The material in the coma is ejected from the nucleus. It should rotate at the same rate as the nucleus, or slower as it drifts away. Another possibility is that the 16-hour rotation period is wrong. Maybe 3i Atlas is actually rotating much faster than we thought. But if that were true, the light curve analysis would show it. Fast rotation creates rapid brightness variations that are easy to detect. Now let's look at what the stacked images actually show. When astrophotographers take multiple exposures of the same object and stack them together, they can reveal faint details that aren't visible in single images. This technique is standard practice in astrophotography, but with 3i Atlas, something unusual happens. When observers stack images taken over short time periods, say 10 or 15 minutes, they see motion patterns that suggest rotation. The coma appears to shift, the jets appear to change orientation, the overall structure appears to rotate. One observer described seeing what looked like 5 objects circling a center. When you stack the images, the shifting coma patterns, dust jets, and inner core movement create this rotating effect. It looks like multiple objects orbiting a central point. But here's the problem. If this is real rotation happening over minutes, the angular velocity is far too high to match the 16-hour rotation period. The math doesn't work. Either the rotation period is wrong, or what we're seeing isn't rotation of the nucleus. Another possibility is that we're seeing an optical illusion created by the stacking process. When you stack images of a moving object, you can create artifacts that look like rotation or motion. But experienced astrophotographers know how to avoid these artifacts, and multiple independent observers are seeing the same patterns. Here's where things get even stranger. Some observers have reported seeing what appear to be dust rings around 3I Atlas. Not just a diffuse coma, but distinct rings or shells of material at specific distances. The nickel atoms need to be ionized and then excited by solar radiation. This typically happens in the inner coma, very close to the nucleus. It doesn't explain why the green glow appears to extend far from the nucleus in some images. Let's focus on the time variation of the green glow. This is where things get really strange. Observers have documented the green glow appearing, intensifying, fading, and disappearing over periods as short as a few hours. In one sequence of images taken over a single night, the green glow was barely visible at the start of observations. 3 hours later, it had intensified significantly. By the end of the night, it had faded again. This kind of rapid variation is extremely difficult to explain with natural processes. Second, the shells appear to be rotating or swirling. This suggests they have angular momentum. They're not just expanding radially outward, but also rotating around the nucleus. How do detached shells acquire angular momentum? In a natural comet, material is ejected from specific active regions on the rotating nucleus. The rotation of the nucleus imparts some angular momentum to the ejected material, but typically this creates spiral patterns, not circular rings. Now let's address one of the most specific claims from the new footage. Multiple observers have stated that 3I Atlas appears to be spinning clockwise when viewed from their perspective. One observer noted that if you invert the pictures, it becomes counterclockwise, but the point is that there's a definite sense of rotation in a specific direction. Here's why this matters. Most objects in the solar system rotate counterclockwise when viewed from above the North Pole of the solar system. This is because the solar system formed from a rotating disk of gas and dust, and most objects inherited that rotation direction. But 3I Atlas is an interstellar object. It didn't form in our solar system. It came from somewhere else. So there's no reason to expect it to rotate in the same direction as solar system objects. However, the fact that observers can determine a rotation direction from visual observation is significant. It means the rotation is fast enough and the structural features are distinct enough that the sense of rotation is apparent. This is unusual for a comet. One observer also noted that most planets rotate on their axis, meaning they spin like a top. But 3I Atlas appears to be spinning in a different way, more like a wheel rolling through space. This is called tumbling rotation, and it's common in asteroids and small bodies that have irregular shapes or have been disturbed by collisions. Let's focus on the most dramatic claim, that visible changes can be seen within 1 minute of observation. If this is true, it has profound implications for what 3I Atlas actually is. One observer stated, "When you visually see it, it might be moving slowly, but you could see it moving for sure. Within a minute, you should see a different shape or a different position." Think about what this means. If the structure is visibly changing within 1 minute, and we're talking about structures that extend thousands of kilometers from the nucleus, then something is moving very fast. Let's do some math. If a structure 10,000 kilometers from the nucleus appears to move noticeably in 1 minute, and noticeably means at least a few degrees of arc, then the linear velocity at that distance is enormous. We're talking about speeds of hundreds or even thousands of kilometers per hour. But material in a cometary coma typically moves at about 1,500 kilometers per hour. At that speed, material 10,000 kilometers from the nucleus would take several hours to move noticeably, not 1 minute. As the solar wind fluctuates or as 3I Atlas moves through regions with different magnetic field strengths, the plasma could brighten or fade. It would also explain the patchy distribution. Plasma structures can be highly organized and localized. They don't spread out evenly like gas molecules do. They follow magnetic field lines and can form filaments, sheets, or clumps. But this hypothesis has problems too. For plasma to emit visible light, it needs to be very energized. Where is that energy coming from? Solar radiation alone typically isn't enough to create bright plasma emission at the distances we're talking about. Now let's consider the technological hypothesis. If 3I Atlas is an artificial object, a probe sent by another civilization, sharpening algorithms can enhance real details, but they can also create false details if pushed too far. The observer was aware of this and tried to find a balance. He also noted, definitely there are sharpening artifacts, so take it with a grain of salt, but we need to see what we need to see to understand what's going on here. This honesty is important. The observer isn't claiming that everything in the images is real. He's acknowledging that some features might be artifacts, but he's also saying that there are real structures present that deserve attention. The fact that multiple independent observers, using different equipment and different processing techniques, are seeing similar rotation patterns suggests that at least some of what we're seeing is real, not just artifacts. The observer who captured the most detailed footage identified 3 images that he considered the most reliable. These were images where the focus was sharp, the processing was conservative, and the structures were clearly visible without excessive enhancement. In these 3 images, you can see distinct structural features around the nucleus. There are jets extending in multiple directions. There are regions of different brightness and color. And when you compare the 3 images taken at different times, you can see that the structures have changed position. This is the strongest evidence for rotation, not just one image that might be misinterpreted, but a sequence of images showing consistent changes over time. This is how rotation is properly documented, through time series observations. The observer noted that some of the structures have no focus and are distracted, but at least 3 structures are really good. This suggests that while some features in the images might be artifacts or noise, there are real structures that are being captured consistently. One of these images was even uploaded to Wikipedia as a reference image for 3I Atlas. This suggests that the astronomical community considers it a legitimate observation, not just a processing artifact. Now we come to the central paradox. We have scientific measurements suggesting a 16-hour rotation period, but we have visual observations suggesting visible changes within minutes. How do we reconcile these 2 pieces of information? One possibility is that 3I Atlas has a complex rotation state. Maybe it's not just spinning around one axis, but tumbling in a more complicated way. This is called non-principal axis rotation, and it can create complex light curves and visual appearances. In non-principal axis rotation, the object wobbles as it spins. Different parts of the object come into view at different times, and the overall appearance can change more rapidly than the basic rotation period would suggest. But even non-principal axis rotation can't fully explain minute scale changes. The fundamental rotation rate is still limited by the object's moment of inertia and angular momentum. You can't spin faster than physics allows. Another possibility is that what we're seeing isn't the rotation of the solid nucleus, but rather the rotation of structures in the coma or magnetosphere. If 3I Atlas is surrounded by plasma or electromagnetic fields, those structures could rotate independently of the nucleus. This brings us back to the plasma hypothesis. If 3I Atlas is a plasma entity or surrounded by a plasma sheath, the plasma structures could respond to the solar wind and interplanetary magnetic field on very short timescales. They could rotate, oscillate, or reconfigure within minutes. Let's compare what we're seeing with 3I Atlas to what we see in normal comets. In a typical comet, the nucleus rotates with a period ranging from a few hours to a few days. As it rotates, different active regions come into sunlight and produce jets. These jets create structures in the coma that rotate with the nucleus. We can see these structures change over time, but the changes happen over hours, not minutes, and the structures are relatively stable. They don't appear and disappear rapidly. 3I Atlas is different. Observers are reporting rapid changes in coma structure, jets that appear to turn on and off, brightness variations over short timescales, and visible rotation within minutes. None of this is typical for comets. Even the most active comets with the most dramatic outbursts don't show this kind of rapid variability. There's something fundamentally different about how 3I Atlas behaves. This adds to the growing list of anomalies that make 3I Atlas unlike any comet we've studied before. The retrograde trajectory, the sunward jets, the perpendicular jet, the unusual composition, the extreme polarization, and now the anomalous rotation behavior. If we consider the technological hypothesis that 3I Atlas is an artificial object, How would that explain the rotation behavior? An artificial object could have active attitude control. It could use thrusters or reaction wheels to change its orientation rapidly. If 3i Atlas is a probe, it might be scanning its environment. It might be rotating to point different instruments in different directions. It might be adjusting its orientation to optimize solar power collection or communication with a distant base. The rapid changes in coma structure could be thruster firings. The dust rings could be exhaust plumes from previous maneuvers. The visible rotation could be deliberate attitude adjustments rather than passive tumbling. This would explain why the rotation doesn't follow the simple patterns we expect from natural objects. Natural objects rotate passively based on their initial angular momentum and any torques from outgassing. Artificial objects can rotate actively based on programmed commands. But this is speculative. We don't have proof that 3i Atlas is artificial. What we have is a growing collection of anomalies that don't fit natural explanations, and that would make sense if the object were artificial. So what do we need to resolve this mystery? First, we need continuous monitoring. We need to watch 3i Atlas for extended periods, hours or days, and document exactly how the structure changes over time. Second, we need high-speed imaging. If changes are happening on minute timescales, we need to capture them with high temporal resolution. This means taking images every few seconds or minutes, not every few hours. Third, we need multi-wavelength observations. Different wavelengths reveal different components of the coma. By observing in multiple wavelengths simultaneously, we can determine whether the rotating structures are dust, gas, plasma, or something else. Fourth, we need polarimetry. The polarization of light can tell us about the nature of the scattering particles. This can help distinguish between dust particles, ice crystals, and plasma. And fifth, we need to correlate the rotation with other observables. Does the rotation rate change over time? Does it correlate with solar wind conditions? Does it correlate with the object's distance from the sun? All of these observations are technically feasible. The challenge is that 3i Atlas is getting fainter as it moves away from the sun. The window for detailed observations is closing rapidly. Let's think about what each explanation would mean. If the rotation is natural but unusually fast, it tells us that 3i Atlas has unusual physical properties. Maybe it's very small and low mass, allowing it to spin faster. Maybe it's been spun up by outgassing torques. If the rotation is caused by plasma structures responding to the solar wind, it tells us that plasma physics plays a much larger role in cometary phenomena than we've appreciated. It might even support the radical hypothesis that 3i Atlas is a plasma-based entity. If the rotation is evidence of active attitude control, it tells us that 3i Atlas is artificial. It tells us that another civilization has achieved interstellar travel and is exploring our solar system. That would be the most important discovery in human history. The stakes couldn't be higher, and that's exactly why we need to investigate this thoroughly, transparently, and without prejudice. We can't dismiss anomalies because they're uncomfortable. We can't jump to conclusions because they're exciting. We need to follow the data. Folks, 3i Atlas is spinning, and the way it's spinning doesn't make sense for a natural comet. Observers are seeing visible changes within minutes. Stacked images show rotation patterns that don't match the measured 16-hour rotation period. Dust rings suggest multiple outbursts with angular momentum, and the overall behavior is unlike anything we've seen before. We have three main explanations: unusual but natural rotation with complex dynamics, plasma structures rotating independently of the nucleus, or active attitude control from an artificial object. None of these explanations is proven. All of them deserve investigation. What we know for certain is that the rotation behavior is anomalous. It's been documented by multiple independent observers, and it demands an explanation. The next few weeks are critical. As 3i Atlas fades from view, we're losing our chance to study it in detail. If we don't act now, we might never know what this object really is. If you watch to the end, drop me a like and subscribe for more updates, and click on the video appearing on your screen right now, where we break down all 12 anomalies of 3i Atlas and explain why this object is unlike anything we've ever seen. I'll see you in the next one.